So welcome to this interesting webinar on finding out how Python, data science, machine learning, and AI can be used to design the best Dream 11 team so that the game, the Dream 11 platform can be used and you could make money, honestly. And how are the different data science concepts stitched together to create a model like that? Okay. So first of all, I would just quickly want everyone present on the meeting on the bridge to post on the chat, what do you think is important to select the right team? What factors do you think are important to select a dream team? So to give you context, Dream 11 is a platform which is like a fantasy cricket league platform where you can go ahead and select a player and create your own team of 11 members. These 11 members are given a score after every match. So after every match, how many wickets did the bowler take? How many runs did the batsman score? Were there any catch outs? Were there any bowled, etc., etc.? All the different ways in which you can create an impact in a game. They are recorded and they are allotted points. And using those points, your Dream 11 team could be created. Okay. And after the end of an IPL season, you are basically going to get some financial reward based on the quality of the team that you had selected. I hope everyone understands the problem clearly. Yes, no?
Yes, sir.
Right? That's great. So, how do you select a player? Tell me. If I give you, let's say, 100 players, okay? Suppose I ask you that you have 100 players and you are supposed to select 11 members out of those. Answer a few questions for me. Okay, I think that would help clarify your doubts. Okay, first question is, should you select only the top players from previous year? Yes or no? I just sort out all the top players last year and I picked the top 11. Okay, some people say yes, some people say no. Why no? Assuming that no new player has been added, if you're saying no, why are you saying no? What is it that I would miss? Yes, please go ahead.
Maybe some new player joined.
No, assume that no new player joined. Now, assume that the number of players in last year and number of players this year is the same.
Then I go for only top players. My answer will be yes.
Why would you select the same players this year? Because they performed last year. So that means the last year performance is the only driving factor behind this year's performance. So imagine if a player, which is one of the best players in the world, had a bad season, had a bad form in one of the IPLs. Now you don't want to include them in your dream team next year. Right? So the answer to that question intuitively is we cannot use past data deterministically to determine the future. Obviously, we will use past records. We will consider past performance in our selection, but past performance should not be the only selection. Okay, there could be the form of a cricketer, right? And consider this: the Dream 11 team score is from last year's IPL or last to last year's IPL. Between last to last year's IPL and the current situation of the player, there are a lot of months where the player could have completely changed their performance. Right? So you should say no to this because you are not sure between last year and this year how performances have changed. And the player performances last year could be depending on a lot of factors. So we should not fixate ourselves on the same factors. Now, what is one of the primary factors in selecting a team? Right? If I have 11 Virat Kohlis playing for me, will I win? Do you think that's the case? No, right? So I need balance in my team. I need good bowlers. I need good batsmen. I need good fielders. I need a good wicket keeper and so many other factors. So the balance. So the Navid, if I keep all rounders in my team, even then I might not win. Okay. If you consider a lot of these individual questions, you will figure out that you will be answering no to most of them. And that is why instead of working on assumptions or let's say biased thoughts, we should actually choose a strategic data driven process to find out the best team. Are we clear? All of you? Yes, no? Yes, Kunal. I mean, I agree that not necessarily, but I would just say that um, keeping all the top players of one kind will not help you win. Okay. So we need to choose a data driven way of finding out the best team, or at least understanding what factors of a player contribute highest to a team win, to a team dream score win. Okay. So I'll just give you guys quick 2 minutes. Go through this content that you see, read through this text, and let me know if you have any questions. Okay, take your 2 minutes and let me know if you guys are any great. If anyone has any questions, please post them in the chat. Great. So let's get on a hands-on session and try to solve this problem. Okay. So how many of you here are proficient in Python? You've done the basic programming with Python course? All of you? You understand what these sentences mean? Or do you want me to explain what these are? Guys online? Just a quick yes, no? Ankita needs an explanation. What about the rest of the group? Explain. Okay, great. So guys, to give you context, Python is one of those amazing libraries which has a large community of developers, practitioners, people who are building amazing products on an everyday basis. And they give out these products for free. Okay, is something called as open source. Okay, what is open source? Open source, think about it as a difference between, suppose Excel as a tool. Can you get Excel for free today? Yes or no?
Yes.
Yes,
No.
we can. I mean, even if you get the hacks and tools, you can get it for free, or at least you can get a free version trial just to look at the sheets. I know you can't edit them. But what is Excel? Excel could be a free software, let's say. Okay, it could be called a free tool. But can you see or edit the code behind Excel? Like, can you see and edit how Excel was built? Think about it. Can you guys do that? Right? So that is the difference between an open source tool and a free tool. In a free tool, the company can give you the service or the product for free, but you cannot look at the code of how it was developed. In an open source tool, the tool is also available for free, as well as the code, the source behind that tool is also available openly. So you can look at it, edit it, and work with it. So Python has these lots of open source libraries. Okay, this is not created by one person, it's created by a group of people. a lot of contributors, 2,000, 3,000 plus individual members that have come together and contributed to a project. One of them is called Pandas. So Pandas is the data science library of Python. NumPy is the numerical computational library of Python. Matplotlib is the plotting library of Python. Seaborn is another plotting library. And warnings is a side module which gives you, some basic, I would say, cosmetic capabilities, so that if there are warnings coming in your code, you can hide those warnings. This is what we are doing practically with this line of code. Whenever I'm getting a warning from my code, I'm filtering those warnings, and what is the criteria that I'm using? I'm ignoring the warnings. Yes, Navid, these are the names of the libraries: Pandas, NumPy, Matplotlib. These are given by the individual developers. So if you just go to Pandas, right? Pandas is a Python-based library. It is an open source library, right? You can see the source repository. You can actually look at the entire code. It is based on the Python programming language, right? It is open source. You can see easy to use data structure. Okay. So these names are given by the developers. So, there's not a lot we can do about the names. We are just aliasing these names with shortcuts so that we can use them in short forms rather than writing pandas again and again. We can just write PD, or rather than using NumPy again and again, we can use NP. Okay. Now we are importing the data set. Obviously, we cannot take data-driven decisions without having the data set handy. So this is one of the data sets that is collected from ESPN, crickinfo.com. Right. So that is a website where you can get the performance of each and every player. Okay. You can see the performance of each and every player and their corresponding Dream 11 scores. Okay. Dream 11 award points to batsmen, bowler, fielders on a point system, which can be found here. So if you just click on it, we'll share this Jupyter notebook with you so you guys can have it. So you can see dream11.com games point system for cricket. For every run you score, +1, boundary bonus +1, 6 bonus +2, 30 run bonus +4, half century bonus +8, century bonus +16. And if you are dismissed on a duck, that means you go into play as a batsman and then you are out at 0 runs scored, then there's a -2 to your score. Okay, any player scoring a century will only get points for the century. No points will be awarded as their 30-run bonus or half century bonus. Additionally, no points are awarded for the centuries in T10 matches. T20 के लिए होता है, T10 के लिए नहीं होता. Okay. Similarly, you have bowling points, you have fielding points, and you have other points. That is why instead of just betting on the batsman, okay, or just betting on the bowler, or just betting on the fielder, we should rather bet on a combination of them. Our intent is to find the right combination. I hope this is clear to everyone. Yes, no? Great. So now this data has the following data points. We have match ID, which is a unique identifier for a particular cricket match. We have player ID, which is unique identifier of a player. We have the name of the player. So you can just map player name to player ID. This will be a unique 1:1 relationship. Bat innings indicates whether the player batted in the first or second innings. Okay, so this can actually help us understand if batting in the first innings or batting in the second innings would create any kind of difference or not. The total number of runs scored by the player, balls faced, what is their strike rate, number of fours hit, number of sixes hit, number of 50s hit, number of hundreds, ball innings, whether the player bowled in the first or the second innings, ball delivered, run given, economy, wicket, catch, stump, run out, Dream 11 score. What we are trying to predict for every player is their Dream 11 score. Are we clear? Every different fantasy cricket platform could have its own way of calculating the score, but this score is what we want to maximize. Okay, so we just quickly load up the match data, match.csv. Now we first do a data exploration. What is data exploration? We basically try to look at what data is available, what it looks. For example, you have Shikhar Dhawan, whose player ID is 427, right? Now, this particular individual row, you have to very clearly understand what this particular individual row means. Okay, let me just quickly change the option to display maximum columns so that these three dots, which represent some columns that are present but are not displayed, let's just change that. Now you see, we have the entire set here. We have the match ID, innings, player ID, player, bat innings, balls faced, runs scored, etc. etc. We have everything. Okay. Now think about this. This player, let's say D.A. Warner, or let's say we pick Shikhar Dhawan, okay, whose player ID is 427. We should first try to explore the data and figure out how this data is structured. Okay. So let's try to find player ID equal to 427. Now see, match ID 1, match ID 6, 10, 14. Can you see a sorted order of matches? Yes or no? Right? So you can see every match, how did Shikhar Dhawan perform? Now you will always see the difference in these matches 1 to 6. That means match number 2, 3, 4, 5 were not played by the teams where Shikhar Dhawan was present. Okay, these are sequential order of matches from the starting of the IPL to the end of the IPL. So if you see, if I try to find out the maximum match ID, it is 636. Approximately one IPL season has 70 matches. So total 9 seasons का data है हमारे पास. Okay. Now, for the different match IDs, it is given which innings did Shikhar Dhawan play. Okay. His player ID will obviously be constant. Player name as well. Bat innings, ball innings, number of balls faced by him, number of runs scored by him, number of fours, number of sixes, 50s, hundreds given by him. Okay, number of balls delivered, number of runs given. Now, if he is not a bowler, he will obviously have 0 balls delivered. Okay, and if he's not a bowler, he will not be able to give away any runs as well. Okay, he'll not be able to take any wickets, but he can take catches. That is why you see non-zero values. He cannot stump because he's not a wicket keeper. It could be a case where he could do a run out, but that's in a separate column. Okay, and if in the cases where he batted, who was he dismissed by? Okay, and dismissal type got Dream 11 score 45. For this particular game, Shikhar Dhawan got allotted 45 points. Now, what I should do is I should just try to quickly validate Stuart Binney here. Okay, STR Binney, because I want to see if Shikhar Dhawan was dismissed in this particular game by STR Binney, we could just find a quick analysis where I could say that the name of the player is equal to Stuart Binney. I see a lot of matches. Can you see match ID 1? Right? In match ID 1, Stuart Binney faced 10 balls, scored 11 runs, but he delivered 6 balls. He gave away 10 runs and he took 1 wicket. Whose wicket is that? That wicket is Shikhar Dhawan's. Okay. I hope I'm clear, everyone, with the consistency of the data. Yes, no? We can do these quick sanity logical steps just to make sure that our data is in the right place. We should have the ability to look at these data points in this way, do those relevant searches, and from those relevant searches, validate if the data is in the right format or not. Whenever you learn Pandas, whenever you learn Python, like in the weekend sessions that I give out at Ivy to multiple batches of different kinds of people, we make sure that it's not just the programming aspect that you learn, it's the logical and conceptual aspect that you should also learn, that this is how things work, this is how data should be validated, checked, etc. Okay. Now I check the information of the data. I see that all my data points, total shape of my data, you can see there are 13,676 rows. This is basically number of players multiplied by number of games played by each player. So 13,676 total records. The total 21 columns, out of which Dream 11 is the score that we try to predict. Rest of the things are input to us. Okay. Then we can do a quick statistical analysis of the data by using the .describe function, where we see match ID, innings, player ID, bat innings. Now, when you look at this .describe, let me ask you a quick question. What is the maximum number of sixes hit by any one player in any one match? Can you guys tell me by looking at this sheet? Can you guys tell me? 17, right? What is the maximum number of fours? Maximum number of runs scored? Right? So using this table or statistical description or statistical analysis of our entire data, we can easily do these quick analysis and answer these quick questions. Okay. So suppose, for example, what is the maximum number of wickets taken in an individual match? You can see 6 is the maximum. Right? Maximum number of catches taken is 5. These are all interesting factors. Right? What is the average run scored? 13. Now, is this the right metric? Tell me that. What is the average number of runs scored? Is this 13.44 the right estimate of the average number of runs scored? What do you guys think? See, the average number of runs scored should not be 13.4 because a lot of these players did not get a chance to bat. If they did not get a chance to bat, their run scored would be 0. And if the run scored would be 0, then that 0 will be driving the average, the mean, towards a lower number, which might not actually be true. Is that clear, all of you? Can we check that? Suppose dismissed by is a column which tells me if a player got out by some player or not. Right? See, for example, here the player did not get dismissed by anyone. That means the player did not play. What is the run scored? The run scored is 16. That means this particular player did not get out in the end. Okay, he was not out. Okay, suppose this player did not get dismissed and scored 0 runs, then there is a good chance that this player did not get to bat. Okay, so in that particular case, bat inning 0. Right? So to find a better estimate, we should filter our data, find a unique condition by which we can identify all the cases where the player did not get a chance to bat, and then find the average runs scored. Is that clear, all of you? Ball faced, could that be a criteria? Could we say IPL such that IPL ball faced greater than 0. This is the case where at least one ball has been faced. Then, if I choose the runs scored column, and then if I find out the mean, then I will get that the average runs scored in each match by each player who's faced a ball is 19 runs. Is that clear, all of you? I hope this makes sense. Let me know, yes or no. Guys online, does that make sense? Great. Now, if we look at the target variable, okay, the target variable is the Dream 11 score. So you can clearly see that the Dream 11 score is a very skewed distribution. Does everyone here know what a skewed distribution is? Yes or no? You guys know what a skewed distribution is? So a skewed distribution is a distribution where it is non-normal. Skewness of a distribution. Check this curve out. If you look at this particular curve, right, you will understand that a skewed distribution is a distribution where the median value, the central value, if I take the minimum value and the maximum value and divide it by 2, the median value is less than the mean. This is called a positive skew. For example, the Indian population age is positive skewed. Why? Because we have a larger population which is younger. So our younger population has a higher frequency. Okay. On the other hand, if you look at, let's say, the Japanese population age, here you can see that the distribution is negatively skewed. So in this particular case, the Japanese population has a higher number of people in the older age segment, right? Then there could be a country where the middle age is the highest frequency, and then young people are equal to the number of old people, which is a symmetrical distribution. So that is the concept behind, that is the concept behind skewness. In this webinar, it's going to be a little difficult to cover the mathematical aspects of it, but I hope everyone got context. Guys online, yes or no? Right? So we check for duplicates in data. Pandas has a lot of these methods where you can easily check for duplicates, easily replace something, rename something, manage anything. Right? Pandas is the complete data manipulation library for Python. Right? You can also check for missing values. Right? You can analyze the total number of matches played. So we can see 636 total matches. You can identify the total number of unique players who have played. So there's 500 unique players. Some players have not played all the matches, right? So we could quickly do a IPL player ID dot value counts. Okay, so there is this player 466 who has played 158 games. Can we figure out who that player is? IPL such that player ID is equal to 466. Suresh Raina, right? He's played the maximum number of matches, 158. Can we try 400 now? This data is not updated with 2022 because it was in Dubai. RG Sharma, this is probably Rohit Sharma, right? 316. Dhoni. right? We all love Dhoni, and he's the third highest match player in the IPL category, in the IPL games, right? Who are the top 20 batsmen? We can find out the top 20 batsmen of last year. So always understand, to determine the match ID for the first match played in the most recent year. Now, if I want to find out how many matches were played, suppose I know that X number of matches were played, right? And I want to find out who were the top 20 batsmen for last year. So first I have to filter my data for match IDs of last year. How will I know match IDs of last year? I will find the highest match ID in the data and then subtract it by the number X, let's say 70 matches. And that will be the last match played last year. Does that make sense? Yes or no? Sorry, this will be the first match played last year. Yes or no? Guys online? I know that 70 matches were played last year. I have data till last year. Now, if I want to find out the top 20 batsmen for last year, I will filter my data for match IDs of last year. How will I filter my data for match IDs of last year? I will find out the highest match ID in my data, subtract X from it, and then fill this match ID that I will get will be the first match played last year. So suppose I have total 600 matches ka data, and I know 70 matches were played last year. So what will I do? 600 minus 70, which is equal to 530. So I will consider match ID equal to 530 plus. So for all the match IDs which are greater than equal to 530, I will find out the top batsman. Am I clear to all of you? Yes or no? I hope I am, all of you. Great. So we follow the same steps. We find the maximum match ID and we subtract 70 from it. So the last year matches are basically all the match IDs where the match ID is greater than equal to the last year match ID. Okay, this last year match ID is basically first match of last year. Then we find out the player runs. We group by each player and then we sum up their runs scored. Okay, so we find each unique player who played last year and we aggregate their total runs scored. Okay, and then we sort this runs scored and find the top 20. We take the head, which is the top 20 cases. And then we use matplotlib. Matplotlib, like I showed you, is the library, which is the data plotting library. We get the matplotlib and we use the horizontal bar. Bar H basically means horizontal bar. Okay, so we do a horizontal bar plot. Okay, I give it a title, top scorers in last year, which you can see here, total runs scored, which you can see here, and this is how I show. So Virat Kohli, Warner, A.B. de Villiers, Rohit Sharma, Rahane, Gambhir, these are people in order. So last year, one player scored 1,000 plus runs, which was Virat Kohli. Then there's David Warner, and just like that, we go till McCullum and Dhoni. Okay, so these are the top batsmen in last year. Similarly, we can do the top 20 bowlers from last year, and we can see that Yuzvendra Chahal was the best bowler. He took close to 30 wickets. And then just like that, we go to Umesh Yadav, who's taken approximately 12 to 13 wickets in last year. I hope I'm clear, all of you, yes or no? Yeah. We can also compare the distributions of players and their Dream 11 scores depending on the fact that they batted in the first innings or they batted in the second innings, right? So you can see for bat inning 0 and bat inning 1, there is not a larger difference in the distribution. The distribution of Dream 11 scores are very similar to each other. Statistically, it would be difficult to explain, but I would still like to cover a feature called the ANOVA test, which is the analysis of variance test, which actually tells us what are the important features, what are the important categorical features to predict a continuous value. So we all know that our Dream 11 score, this is a continuous value. Why continuous value? Because it is a number, right? And we have categorical data points in the data. What are the categorical data points? If I just quickly look at IPL, you can see dismissal type and the name of the player. Okay, there are some categorical data points. Now what I can do is I can try to create a statistical measure using which I can find out if out of all the categorical variables available to me, do they help me in predicting my continuous value, my Dream 11 score better or not? Okay, so this is a piece of code which basically helps you understand. Now think about it. Very intelligent question I would like to ask you. When we look at a lot of these columns in our data, we see that they are numbers, but are they really numbers? Bat inning, it is number 1. Does this 1 have any significance with the innings? For example, runs scored 14, this 14 has a significance with the runs scored. But bat inning 1 has no significance with innings in general, right? So they are binary, that is correct, Navid. And by binary, what we mean is that this number is actually a category. I could easily say bat inning first or bat inning second. If 0 is first, then I could say bat inning second, ball innings first, right? I could just convert them into categories. That is why you will see, for example, let me show hundreds. Hundreds में जब 0 है, I could say yes or no. How do you classify? 100 is not a number, right? 100 is like yes. Now is correct. It's like true or false, yes or no, scored or not scored, right? 50s, hundreds, they are all like that. Okay, stump or not, run out or not. They have no numerical significance. That is why we will treat them as categories. Okay. So this will actually be categorical. This will be categorical. Okay. So innings, bat innings, ball innings, 50s, hundreds, wicket, catch, stump, run out. We want to know which of these categorical values affect our continuous output Dream 11 score. Okay. And we can see for most of them, bat inning is correlated because its p-value is less than 0.05. Now, this is a technical concept that we teach in our classes, but for the purpose of this bootcamp, you just have to understand that if the p-value is less than 0.05, you can consider that that particular column, that particular categorical column, is significant in predicting Dream 11 score. So bat inning is correlated with Dream 11 score. Why? Because the p-value is 0.0, which is less than 0.05. But inning is not correlated with Dream 11 score. Why? Because its p-value is 0.24, which is greater than 0.05. Okay, so just like that, we find out the columns which are important and which are not. Top Dream 11 points in last year. So this is the Dream 11 points. Virat Kohli highest, Warner, AB de Villiers, Watson, Boris, so on and so forth. Okay, now we come to the machine learning part. We first split our data into the features and target variable. What is the input? All the features about the game. What is the output? The Dream 11 score. So we create an X, which is all the input. We create a Y, which is all the output. Then we convert our Y into an integer format, although that wouldn't have been necessary, but it's safe to keep these transfers into integers so that we can use them easily. Now, imagine this. Wickets taken and runs scored. Wickets taken will be in what range? Minimum 0 to maximum 11? Yes or no? I think 10. Can't go 11. One bowler can take a minimum of 0 wickets and take a maximum of 10 wickets. Yes or no? Is that clear, everyone? On the other hand, a run scored, one batsman can score a run of 0, and let's assume that the maximum cap is 250. They can go up till 250 runs. Now, think about the scale of these two features. One scale is between 0 to 10, another's scale is between 0 to 250. Now, can I say that one wicket taken is equal to one run scored? Yes or no? Can I say this? Can I say that one wicket taken is equal to one run scored because both the values are one? Can I compare these two numerical values? I cannot compare these numerical values because they are relatively different. They are relatively different because they have different scales, right? That is why I do a process called normalization of my data. I normalize my data so that my model learns the effect of wickets taking relative to effect of run scoring. It should not treat one wicket taken equivalent to one run scored. Why should it not take it? Because they are in different scales, right? That is why 0 to 10 wickets and 0 to 250 runs may, I can assume that scoring 40 runs and taking one wicket could be the same thing. Why? Because I will normalize my data so that my machine learning model learns the relative effect rather than considering numerical similarity just because they are numerically equal. Okay, it's like the difference between salary and age. Someone with age 40 years and someone with salary 40 rupees. Can you compare them? Never, right? Because age has a different scale, salary has a different scale. Okay, so we normalize salary and normalize age and consider the relative change in them. And that helps my machine learning model. Are we clear, everyone? Yes, no? All the members in the group, are we clear? Great. So now, after scaling our data, we just quickly, right? Now we split our data into training and testing, right? And we create a scikit-learn metric. Now, what is a metric? Metric is a way to identify the goodness or badness of a model. Metric is basically an example, let's say accuracy or error, right? If one model has 80% accuracy and another has 90% accuracy, I can choose the higher one because accuracy as a metric helps me choose a better model. Similarly, error 20%, error 30%. I can choose the lower one because lower error indicates a better model, right? So we can do that. That is the mean squared error that I have imported. Then I'm trying to use out multiple algorithms. I'm trying a decision tree regressor, linear regressor. If you don't know about these models, don't worry. In our IV sessions, we cover them in a lot of depth. So if you've already enrolled or if you're going to be joining IV, you'll get to learn all of this. And even if you don't know them now, you can explore them later on the internet. These are standard machine learning, classical machine learning algorithms that have performed really well on data points of different types and sizes. So linear regression, decision tree, random forest, and add a boost regressor. We create all these models and we try performance of our machine learning model on all of these. So we train on training data. We make the model learn on training data and test its performance on testing data. Now, whichever model performs the best on testing data, that is the model we choose. Because testing data was not seen by the machine learning model. The machine learning model only saw training data. Testing data was not seen by the machine learning model. So if a model can perform with higher accuracy or with lower error on a data set it has never seen, then that is the true or authentic potential of the model. And based on the authentic potential of the model, we will choose which model to get. Machine learning is based on algorithms. Yes, Navid, purely based on algorithms. Okay. Then we train all of these 4 individual models, and then we basically write a piece of code to combine their performance and look at them. So you can see 4 of these models, they had training accuracy, test accuracy, they had the root mean square error, and they had the name of the models. Now, root mean square error. Root mean square error helps us understand which is the best performing model. Because root mean square is an error, RMSE, root mean square error. Because it is an error, the lowest error is the best performing model. So you can see that the linear regression model is the best performing model. And so we finally make our predictions from on the test data of our linear regression model. And what is our prediction? This is our prediction. Okay, these are the dream IPL scores of some of our players. Okay, these are the scores of some of our players. Now, what can you do? Suppose you want to create a team, or you have options between 2 teams. Okay, you have options between 2 teams. What you can do is you can find out the Dream 11 scores, the aggregate Dream 11 scores of those 2 teams, and select which team performs better on an aggregate level. And that will help you understand which team you can select. So once you understand what Dream 11 score you can expect, okay, once you understand what Dream 11 score you can expect, you can try out different combinations of 11 players each and find out the best Dream 11 aggregate score of 11 players. And you can see from this understanding of the model, now we've not told the model the actual point score, right? We went to the Dream 11 Fantasy Cricket League website and we found out the rules for assigning Dream 11 points. We did not tell that to our machine learning model, but our machine learning model actually figured out the points assigned in a relative format to all of these individual variables. So it says that runs scored has the highest allotment of Dream 11 score. Wickets taken is next. Catches taken, balls delivered, stumps, fours, sixes, 50s, 100s. They have these relative importances. So if you want to select a team which has the highest Dream 11 score, you'd be looking for a team which has high run scorers, high wicket takers, which is very logical. Whenever we want to select a team, we would select a combination of good batsmen and a good set of bowlers. High runs scored, high wickets taken. Then we also want good fielders, so there is catches, right? Then there is stumps, so we need a good wicket keeper. Then number of fours hit, number of sixes hit. These are factors that directly impact the Dream 11 score and the performance of the team. Okay, that was it for this webinar, guys. If you guys have any questions, please let me know. Please do also fill the feedback form. And yes, you will get the code and you will get the code and the data set, Mayur, don't worry. Thank you for appreciating the webinar. What about the budget of making such a team? So Kunal, what happens is you can actually have a budget machine learning model as well. And for all the combination of teams you create, you can actually predict the budget as well as the performance. And then you can create a ratio, right? Score, Dream 11 aggregate score by total budget. Then you can try to optimize and find the highest score you can get for a particular budget. Does that make sense? Navid, you will predict for each player, right? And then sum the scores. That will give you the aggregate. That's why I'm saying aggregate score of 11 players. Okay, guys. So thank you for joining this webinar. I know a 1 hour webinar does not justify the amount of Python content, the amount of Pandas content that we actually deliver, or that is needed to be a data scientist, to be a machine learning engineer or data analyst. But I hope we were able to add some value, give you guys some context and understanding of the field. And please do connect with the Ivy team for any further feedback, as well as for any other topics or any concerns. If you want to join the program, if you want to join the projects, machine learning, Python, data science courses.
Sir, I have one question left.
Yeah, please go ahead.
Sir, do we need statistics also in this machine learning?
See, it is, Navid, you asked a good question. I appreciate asking the question, but it's truly that any algorithm you want to implement, है ना? And you would not be sticking to just data science or machine learning, right? You would want to go to deep learning, you'd want to go to AI. So you must have a strong statistical base.
Yeah.
Right.
Okay.
And I understand that you don't have to be a statistics expert, but you should know the basics, the larger logic, the concepts that will help you progress in your career faster than if you would have not known any statistics and you're just implementing machine learning models.
Yeah, I got it, sir. Thank you.
Okay, great. Thanks, everyone. Have a good day. I hope to see you guys in our sessions or see you guys in some other webinars or boot camps. Have a good day. Bye.